Here on slide 15 we have an application using these kinds of shapes, circles, polygons, and in this application we also have a square, which we didn't show the implementation details for, but it would be similar to circle and polygon. Now in this application, because the shape class is abstract, as we talked about before, if we attempted to say shape and then an object name like S1, the compiler would yell at us that shape is an abstract class and it's not possible to create an object whose data type is an abstract class. But we are allowed to create circle objects. C1 here is a circle object. S1 here, which maybe I should have called this SQ1 to differentiate it from the shape, but anyway, S1 is a square object, and P1 is a polygon object. Now, the array X and the array Y here contain the XY coordinates of the 5 points that make this polygon P1. So the polygon P1 has 5 points in it, which are 1, 1, and then 3, 1. Notice that the X coordinate is 3 and the corresponding Y coordinate is 1. And then 8, 2, 9, 3, and 4, 8. So this polygon would have 5 vertices and 5 sides to it. Now that we've created those specific kinds of shapes, a circle, a square, and a polygon, let's draw each one. C1.draw we'll call the circle draw function. S1.draw is the square draw. P1.draw is the polygon draw function. When I hit the closing curly brace at the end of main, the application is over. These local variables C1, S1, and P1 are deallocated, and in the process the destructors for those things are called. Alright, so the output on slide 16 of the program on slide 15 would show first the circle being drawn, the square being drawn, and the polygon being drawn in some sort of graphical screen. And then I want you to notice that the destructors are called in the opposite order in which the objects were created and their constructors were called. So the circle C1 was created first, followed by the square S1, and then the polygon P1. And when we leave the main function and the destructors get called, it's the polygon that's destroyed first, then the square, then the circle. Okay, so this is not an accident. This is not a feature of the GNU C++ compiler. This is specified in the language that destructors are called in the opposite order of constructors. So this simple program on slide 15 created and drew 3 shape objects, namely a circle, which is a kind of shape, a square, which is a kind of shape, and a polygon, which is a kind of shape. Of course, a real graphical application would have to manage some arbitrary number of graphical objects, that is, arbitrary number of shapes that are created and destroyed by the user on the fly. So on slide 17 and on slide 18, we're showing a slightly more sophisticated, still very simple, but slightly more sophisticated program that uses a vector of pointers to shape to keep track of the shapes that currently exist in the application. So we've included vector, and in main we have declared SV as a vector of pointer to shape. Initially that vector is empty. Now, to add shapes into the vector, we're going to use new to create a kind of shape in the dynamic memory area, that is in the heap. Here we're creating a new circle with a center located at 5, 5 and a radius of 1.5. We'll get back from that a pointer to circle, and we're going to use pushback to push that pointer to circle onto the end of SV, that is because a circle is a kind of shape, we can store this pointer to circle in our vector of pointers to shapes. Then in the next line, we're doing the same thing with a square. Here we're allocating a new square with its lower left corner at 0, 0 and its upper right corner at 10, 10. We get back from new a pointer to a square, and we push that to the back of our vector of pointers to shapes. Notice in both of these cases, new circle and new square, that we're using the constructor to create an unnamed circle and an unnamed square. In the same way that if we were to say new int, that would create a new unnamed int in the heap. Creating a polygon is a little more complicated because, of course, we have to have our array of x coordinates and corresponding array of y coordinates of the same size. And then we can allocate a new polygon where the points are at those xy coordinates and dim is the number of points in the polygon. So now we have SV is a vector of 3 pointers to shapes. The first pointer is actually a pointer to a circle, the second pointer is actually a pointer to a square, and the third pointer is actually a pointer to a polygon, but since these are all kinds of shapes, we can treat them as pointers to shapes. Then we're using our for loop here, with I going from 0 up to 1 less than the size of our vector. We're going to first draw the currently pointed to shape. So SV sub 0 is going to be pointing to a circle, and we're going to call the circle draw function. Then we're going to scale the pointed to object to double its size and redraw the object by calling the draw function again. So SV sub 0 is actually pointing to a circle, so we're going to draw the circle, we're going to double its radius, and we're going to draw it again. SV sub 1 is pointing to a square, so we're going to draw the square, double the size of the square, and draw it again. And then SV sub 2 is pointing to a polygon, so we'll draw the polygon, double its size, and draw it again. Now normally once we have used our various shapes, since we have dynamically allocated them, we would need to delete them, and we would probably have a separate loop that would do that. But here we're crowded for space on these two slides, 17 and 18. So I have put the deletion of the allocated objects right inside the loop. And actually here I see I made an error. Instead of saying delete star IT, there is no such thing as IT in this program. We're not using an iterator, we're using an integer subscript. So that line should say delete SV sub I. Alright, so instead of delete star IT, that should say delete SV sub I. And that's it. So we've got this little program on slides 17 and 18 that sets up a vector of pointers to shapes, then allocates 3 kinds of shapes on the fly, on the heap, storing those pointers into our vector. Then we traverse through the vector and draw and scale and draw each shape, and then delete the shape when we're done using it.